Welcome back. In this session, we'll continue with the discussion on Z transform. Let's learn a few more examples. Let's suppose we want to take the Z transform of x of n, and let's suppose x of n is an u of n. So what's the Z transform of this? So Z transform of this can be written as using the definition of Z transform x of n u of n. So using the substituting the value of x of n in this, we have a is for n, u of n, 0 is for minus n. Using the definition of u of n, which is equal to 1, when n is greater or equal to 0, n is equal to 0, and n is less than 0, using it here. This summation converges to n is from 0 to infinity. Here is for n, here is for n is z of n. So this one converges to this. Now this we can write as n goes from 0 to infinity, a z inverse n. So x of z, we can write it as, now expanding this summation, we can write it as a z inverse raised to 0 plus a z inverse raised to 1, a z inverse raised to 2, a inverse raised to 3, and so on. This sum goes up to infinity. So anything raised to 0 is 1. So this will be a z inverse square plus a z inverse cube plus so on. Now from this we can check that this is a GP, and the common ratio of this GP is a z inverse, and we know the sum of a GP, if it runs from this 1 to infinity, the sum is given by 1 by 1 minus r if magnitude of r is less than 1. If the magnitude of this r is less than 1, then we can write the sum of the GP as 1 by 1 minus r, and substituting the value of r here, we say the Z transform is equal to this if a Z inverse magnitude is less than 1. So okay, if we write it like, you can write it as this, you can say this is a by z is less than 1, or if I say magnitude of a is less than, magnitude of a by z is less than 1, or you can write it, if I multiply both sides with magnitude of z, so this is the r, then with the value of z, so if z is greater than a. So this is the Z transform. In other words, Z transform of A is for m u of n is simply 1 by 1 minus a Z inverse if magnitude of Z is greater than magnitude of A. Alright, so in other words, the Z transform of this exists if this is true. Now what is the meaning of this? Now we know that if Z is written as r j omega, and if we take the mod of this defined as a circle on a complex plane where the radius is r, so we can write it as so this defined as a circle where the radius is greater than a. So if we have a look on the complex plane, and if we draw the complex plane for this, we can say this is a part of z, and this is imaginary part of z, and if we draw a circle on this z plane, so this is the circle, and if the radius of the circle is magnitude a, and if z is greater than this a, z is greater than a, outside this circle whose radius is a, then we say Z transform exists, means Z transform is equal to then equal to this. Now why can't the value of Z become equal to a or less than a? You can see if it is equal to a. Now if the Z is exactly equal to a, from this you can say this will be 1 by 1 minus a, and Z will cancel. This will be 1, and this will be 1 by 1 minus 1. So 1 by 1 minus 1 is 0, and you know that will be infinity. So this will be simply infinity. So at z equal to a means when z becomes equal to the magnitude of a, there is a pole at this point, and that's why this cannot include it. And we know the function will be simply in the function, the z transform will not exist at this point. That's why this z transform, the z transform, this cannot include this. So in short, what we learned the z transform of a raised to n u of n is simply 1 by 1 minus a z is provided the magnitude of z is greater than the magnitude of a. This is a very important result that we'll use again in z transform. So you must remember this z transform. Now one important implication of this is if you want to have the z transform of u of n. If I substitute a equal to 1 in this will be 1 raised power n, that's 1. And if you multiply 1 with u of n, it will be u of n. From this we can get the z transform of u of n. This will be a is equal to 1. So this is 1. So the z transform of u of n is 1 by 1 minus z inverse if magnitude of z is greater than 1. In other words, the z transform of unit step sequence exists if ROC means if the radius of this z is greater than 1 or if it includes outside this unit circle. So if I say z is equal to exactly 1, again you can check this will be 1 by 1 minus 0. So this cannot include. So z transform of this cannot include this because it will be infinity. Again it cannot exist. That's why z transform of this cannot include this unit circle. That's why this cannot include this unit circle. Alright. So this is the z transform of a raised power n u of n. Now next we are going to solve one more example for this. So let's learn the z transform of x of n, which is minus a raised power n u of minus n minus 1. What's the z transform of this? What is the z transform of this? Alright. So this, what is the z transform of this? Now using the definition of z transform, we know the z transform of x of n. We write it as x of z, and using the definition means using the formula, we can write it as minus infinity to infinity x of n z raised to minus n. Now substituting the value of x of n, we have n running from minus infinity to infinity and running from minus infinity to infinity. X of n is simply e raised power minus e raised power n u of minus n minus 1 e raised power minus n. Now before I use the definition of u of minus 1, let me take the minus outside. So this will be e raised power n u of minus n minus 1 is e raised power minus n. So using the definition of u of n minus 1, so this is u of n minus 1, and we know it's equal to 1 if minus n minus 1 is greater or equal to 0, or I can write the same condition like if minus n is greater or equal to 1, or I need the value of n is less or equal to 1, minus 1, sorry. If n is less or equal to minus 1 is multiplying both sides by minus 1, and this will reverse. So using the definition here, we'll say this is sum converges to minus infinity to minus 1, and rest of the values are 0, means if n is greater than 1, this u of n minus 1 is 0. So you can say u of n is 0 minus 1 after using the definition. Now what we are going to do in this, we are going to replace n by minus m. So let's replace n by minus m. Now one more thing, before I do that, if I write this sum from minus infinity to minus 1 or minus 1 to minus infinity, it doesn't matter. It does not matter anything. So whether I write this sum from minus infinity to minus 1 or minus 1 to minus infinity, this means one and the same thing. So I can write it from like this and go from minus 1 to minus infinity. a raised power n is a raised power minus n, so this will move on the same thing. So now if I replace n by minus m, if I replace n by minus m, or simply m is equal to minus n, this sum, this formula will be equal to, this is, if we put m when n is minus 1, m will be plus 1. So m is 1. When n is minus infinity, m will be plus infinity. So it's equal to this. And this will be a raised power minus m now, z raised power plus m. So we can write it like this. M is 1 infinity, a raised power minus 1. Taking the m outside and writing it for both. Now expanding this sum, we can write it like a inverse z m raised to power 1, that's 1 square a inverse z q and so on like this. Now we are going to take a inverse z common from this. This will be 1 plus a inverse z from this, and from this we'll have a inverse z square and so on. We're taking this common. Now again you can see this is a GP where the common ratio is a inverse z, where the common ratio is a inverse z. So we can write it minus a inverse z divided by 1 minus 1 by a inverse z if a inverse z magnitude of this is less than 1. So again you can see this is a GP and this converges to z, GP converges. This is equal to this. Now we can write it a inverse z 1 by a inverse z. Now dividing the numerator and denominator by n. Remember this is true if a inverse z magnitude of this quantity is less than 1. Now dividing the numerator and denominator by this quantity, write it like minus 1 by a z inverse minus 1. Now taking the minus 1 common from numerator and denominator, will have 1 by a, sorry, not inverse, a z inverse, a z inverse like this. And again, this is true if this is true. Now if I write it like this, I can write it z by a less than 1, and if I take a on the left side, this will be z, this is true, and magnitude of z is less than 1. So the z transform is equal to this if this is true. If this is true, in other words, z transform of minus a raised power m q of minus 1 is equal to 1 by 1 minus z inverse if magnitude of z is less than. So again, this is a circle whose radius is less than this. So in other words, if z remains inside the units, inside the circle of radius, there's how much of radius a, magnitude of a, then we say the z transform exists. Means if z, the value of z remains inside the circle, we say the z transform exists. All right, now one important thing here before I proceed, z transform of a raised power n u of n is equal to 1 by 1 minus a z inverse when magnitude of z is greater than a, and z transform of minus a raised power n u of minus n minus 1 is again equal to 1 by 1 minus a z inverse if z remains less than a. So the ROC here is, the ROC is this, ROC. Now you can see the z transform in both the cases is same. So the z transform in both the cases you can check is same. Z transform for this is this, z transform for this is this. You can check the z transform is identical. What's the difference? The difference is in the ROC. So you can see the ROC of the two are different. This is a causal signal. Causal signal means one which is a 0 for negative values of n, and this is non-causal, and this is a non-causal signal. you can see the Z transform of a causal signal exists for outside the unit circle, and the Z transform of non-causal signal is inside the unit circle. Means it exists when the region of convergence is outside the circle and inside the circle, respectively, for causal and non-causal signal. This is very, very important. We are going to use this. So memorize these two formulas. You have to memorize these two, then we can proceed. So these are very, very important two formulas. So from this you can get the Z transform. Second one, you can get the Z transform of minus U of minus n. Calculate that and see what is the result. Calculate it from this and check the result. All right, so the Z transform of this minus n U of minus n minus 1 is all right. So let me end this session here. In the next session, we are going to learn the properties of Z transform. All right.